Hello, everyone. We are about to start the webinar today with the Emeralds together with Spine Project. We are waiting for just a few minutes, a couple of minutes for the attendees to enter in the room, and then we start. So welcome, everyone. We are about to start the webinar together. The Emeralds project and the Spine projects are working together on this achievement today, talking about advancing public transport intelligence across Europe. This is half an hour webinar with both the project present here, but actually, we are having the coordinator of the Spine project, who will introduce the Spine project and the work that they are performing in the project. And then we will have the Spine use case representation from City Antwerp, and talking about smart traffic management in Spine, talking about the use case in particular, and then we are closing with the use case from the Emerald project, and we are talking about the city of Riga. So I'm going to present the speakers today, and we start with Sisi Coronaiu, who is the project coordinator. Sisi, good afternoon.
Hello, everyone. Hi.
Hello, everyone.
Hi, Maria Letizia.
Hi, Sisi. So the floor is yours. You are about to introduce the Spine project and talking about smart public transport initiative from climate neutral cities in Europe. The floor is yours.
Perfect. I hope you can see my screen. All good.
We can.
Thank you very much. So yes, indeed, we will talk about Spine. Hi, everyone. I will present Spine, which is a Horizon Europe project as well for public transport, dedicated, let's say, to public transport. So just to give you an idea, first of all, what we are doing, it actually started on the same time as Emeralds. It was on the 1st January of 2023. It has a duration of 4 years, so we have 1 more year to go, a budget of around 17 million euros and 39 partners in total. The 2 main goals of the project is the increase of share of public transport, what we call the modal split with different modes, and then the increase as well of user satisfaction with public transport. Of course, there are some other goals as well, the reduce of cars in congestion and reduce of CO2 emissions, as well as many other goals, individual per city and per living lab, that is basically within their sustainable urban mobility plans, the SAMPs that each city has. So Spine's mission is to improve quality of life, equity, and social justice. And how we do that? Basically, we try to reinforce the public transport system through the integration of new mobility service, connected, automated mobility, sharing schemes, active mobility, and micro-mobility. And just to give you an idea, this whole, the call for this specific project and our sister project Upper was done just after COVID. So it is an effort, let's say, to reinforce the public transport that had seen a decline because of the COVID. So all participating cities, as I said, have a SAMP in place, and we try to build on that and propose new services. So, apologies. back to that, to the cities. So we have 11 cities, 4 lead and 7 twinning cities that you can see here in the map around Europe, with 50 plus, I think it's 55 co-created solutions. There is a combination of pull and push measures, which means that it could be technological innovations, non-technological, but also some policy-based measures. So for example, charging schemes and low emission zone congestion. But a big part as well is the citizen engagement activities. So we are using co-creation, awareness raising campaigns, pop-up exhibitions, etc., to initiate what we call behavioral change and trying to convince people to use more public transport than individual cars. So our approach in general started with a landscape analysis, as usual in this project. Then we developed some specific digital tools that could meet the needs of the cities. These were applied to the 4 lead cities, then to the 7 twinning cities as well. And of course, we have some dissemination, transferability, upscaling opportunities. And at the end, we will also have a local policy framework, which will start next year, which is our last year in the project. And here I put a few of the implementations done in the main 4 lead cities, just to give you an idea of what we're working on. And most of them have multimodal hub. It is one of the things that we use a lot in Spine, because we consider, we want this multimodality. So we want a place where a person could use different modes and easily findable, because it's very important, with real-time information, with accuracy as well, no delays, or even if there are delays, notifications about these delays, etc., etc. So here in Antwerp, we can see some information screens, some signposts that have been implemented in the city. Apologies, the quality of the photo is not very good, but yeah, this is the signpost that you can see here with Elm technology. There has been a very big work on the journey planner that they created. They did a complete redesign, and they actually also won the Belgian Smart Mobility Award for this for 2025. There is a combination of transport modes, different nudges to nudge towards a more sustainable behavior, different types of routes, mobility map, accessibility map, a lot of work there. And they also have the traffic management and PT prioritization. The details you will see afterwards in the presentation of Nadine. In Bologna, for example, you can also see the mass application. There was also a micro incentives campaign that is underway with different prizes for sustainability and mobility and PT. There are 3 multimodal hubs that have been created, including accessible EV charging station, accessibility features, ramps, braille audio, videos with subtitles, etc. And they also use simulation for their low emission zone and the campaign that they're doing for City 30. So no more than 30 kilometers per hour in certain areas. In Tallinn, we also see again the multimodal hubs. They have a lot of park and ride, some new facilities, information screen, and they try to promote that. They also did the cargo bike renting service, and they used environmental sensors to actually 2 CO2 sensors that have been installed either in a stable pole, as you can see in the photo here, or in the tram line. This is the white line that you see here. And finally, last but not least, Las Palmas, we also have a multimodal hub where they redesigned completely. They did some new bus stations, some wayfinding design that you can see here from scratch to help people find their way. And the traffic simulation and demand profiling that has been incorporated with also the analysis of 2 specific intersections that are very, very busy. So that is a very quick wrap up of the project. Of course, if you're more interested, we still have 1 year to go in front of us. So here you can see our social media, and you can follow and see more information, hopefully with more results coming up this year. Thank you. I'll stop.
Thank you. Well. Thank you very much, Cici. Very interesting. And please, for the attendees, we invite you to follow the project, the Spine project. We added in the chat the website address, so the URL. So you can find there all the social media channels reported there, so you can follow the project in the next year and beyond, obviously. So thank you very much, Cici, again. So now I think it's time for Nadine Rabia from Unix Traffic, which is one of the partners of the Spine projects. But I leave the floor to Nadine to present herself and to introduce herself and to present the slide deck and the thematic that she is going to cover. Thank you, Nadine. The floor is yours.
Yes, thank you both for the introduction. I hope you can hear me and also see the
very
presentation.
Well.
Okay, very good. Yeah, then also welcome from my side. Yeah, as mentioned, Nadine Rabia, my name. From Unix, and today I would like to present how Spine Smart Traffic Management leverages structured data validation and quality analysis using the city of Antwerp as an example. And yeah, so we'll see how these approaches directly support more reliable and user-oriented mobility planning with the following agenda. So first of all, I would like to start with the question, why is data quality so important in mobility planning? So in modern urban mobility, reliable planning depends on high quality and trustworthy data. And most of the time, cities face challenges such as multiple data sources, having complex urban networks, a need to deliver solutions that truly serve users. And so Spine's approach here is to use structured validation and continuous quality analysis to overcome these challenges. Taking a deeper look into the technical framework for the smart traffic management solution is first of all the integration of heterogeneous data. So as Sissy had also shown, we have multiple cities involved within Spine, and they all have different kinds of data present. And for the smart traffic management solution, especially the signalization data, signal program data, but also the public transport raw data is of interest, which means concretely that public transport position data is shared via telegrams, via detectors, GTFS data, GPS, but also simulation data. And all this is harmonized into a unified model, enabling cross-city analytics and benchmarking. And so, yeah, basically this technical foundation is essential for robust validation and actionable insights. Going into the validation process, which is systematic within Spine, we first had asked ourselves if all data sources are complete and accurate. Next, we assessed the output correctness. So do all algorithms produce plausible and actionable results? And finally, we test each module. So from public transport data conversion to the green wave analysis, then also integrating simulation data and so on. So all that goes into both real world and synthetic data conditions. And this process ensures that the tools and solutions are reliable and ready for deployment. But to give you a more concrete example, I would like to give you some insights from the city of Antwerp. So thanks to the OSID conform data provided by Antwerp, we were able to quickly establish the common data model. So we had used, or like the city of Antwerp is using standardized formats, which streamlines the integration and analysis process. And with this solid foundation, our first step was to have a public transport trigger analysis. So means how often do we receive messages from public transport vehicles at beacons, in this case, along the corridor, which you can see on the right-hand side. And this allowed us to assess the quality and consistency of travel time data for public transport along the corridor. And by let's say, matching it all together, so bringing public transport data and signalization data together, we could kind of provide a green wave analysis, which you can see in the graph in the center. So basically having the green bands, which span from the left bottom to the right top, which indicate the signalization of the green times. And you can also see the blue lines, which indicate the public transport trajectories along the corridor. And ideally, they would be in alignment so that this so-called green wave is implemented. And our analysis had shown that often there is the approach at the end of the green window, which gives an indication of the risk of stops and delays. I mean, this also depends highly on public transport stops, which are along or between intersections. And therefore, you can also see that there's a higher curve of the trajectory, which indicates that the bus is much slower than the planned 50 kilometers an hour. And you can also see that there are some, let's say, data points missing where the trajectories do not constantly go throughout the corridor, which indicates that the public transport messages are not arriving, for example, due to a detector inaccuracy, or that there are some like detours taken and so on. And to improve this, we would recommend most importantly, to monitor and check public transport detection technology, but also in this case, if this had been kind of resolved, dynamic offset adjustments are very important. But in summary, for the city of Antwerp, we could say that standardized data enable rapid and in-depth analysis, revealing both strengths and but also areas for improvement in public transport signal coordination. Now, taking also a look into or insights into the other spine cities. So the spine validation approach is in this case flexible because it can be tailored to each city's unique data. So learning from the leading cities and also taking it on to our twinning cities brings in the city's unique data, infrastructure, and policy environment. And for cities that are lacking comprehensive real-world data, simulation and synthetic data had shown that these are valuable tools to test and refine the solutions before the full deployment. Then cities can also quickly identify issues, adapt strategies, and scale up successful solutions by continuous validation and KPI monitoring. And at last point to mention here is that the smart traffic management framework isn't just for the leading cities as mentioned. So that the, let's say, knowledge transfer is given to help and create lasting sustainable impact across Europe. Taking a look at the impact on mobility planning, what does that mean for cities? So a validated data enables robust and evidence-based decisions. Improved public transport prioritization leads to better punctuality and a more positive passenger experience. And simulations and real-time data support the what-if analysis, helping cities to plan strategic interventions with confidence. Coming to a conclusion, so the development and deployment of the smart traffic management solutions mark a significant milestone in SPINE's mission for climate neutral urban mobility, which means that harmonized data models allow cities to integrate diverse mobility data for a unified actionable view. Advanced analytics and simulation support cities in optimizing traffic flows and improving public transport reliability. SPINE tools bridge the data gaps to empower proactive decision making, even when data is incomplete. And as a last point to mention is that these innovations provide a robust foundation for sustainable transport strategies and that they are also ready to scale to more cities, supporting Spine's vision for smart, inclusive, and environmentally responsible mobility. That would actually be already it from my side for the smart traffic management solution within Spine. Thank you already for listening, and yeah, then I would hand over.
Thank you very much, Nadine. Very interesting your presentation. Actually, the use case in particular that you are covering this presentation. So there is one raised hand from one of the attendees or the participants. Sorry. Yeah. So let's see if it's possible to include them to the discussion. So I open the floor to the audience and for the questions that is there. Yeah, please go ahead. Can you talk? I think it's muted. So let's see if they can add their question in the Q&A box.
Sorry,
and
Marilda,
hi.
I accidentally raised my hand. Okay, sorry.
Oh, no problem. Yes. Okay, so if you have questions, please add in the Q&A box on the bottom of the screen. So now it's time for the city of Riga from the Emeralds project. So I'm introducing Yuris Kondratenko from Grupa 93, and hi Yuris. We can see your screen in the presentation mode.
Yes, thank you.
So the floor is yours. Thank you.
Thank you. I represent urban planning consultancy Grupa 93 from Riga, Latvia, and our use case in the Emerald project is on use of public transport data for urban planning. So we focus in on insights for route network planning, as well as fleet optimization, as well as operational management. And our use case focuses on the points raised before. Basically, there is a lot of data, and not much is used. And we are filling this gap with the Emeralds project. And yeah, something I would like to mention is that in this project we have used a lot of public participation and involvement of different stakeholders in this in the process in the 3 years project. And yeah, basically the next is a demo of this project, which provides a very good, concise information on what we did. Here we go.
Hi, my name is Christine from Group 93, and today, as the owners of Use Case 3 of Riga case, we are presenting the final demo of trip characteristics inference and traffic flow data analytics. Use Case 3 focuses on public transport data management and analytics. But before going into technical details, I want to mention a few challenges. The city uses a check-in only system, and data so far is mostly used for general statistics. Limited capacity to store and process large datasets makes it harder to understand real travel patterns and demand. This brings us to the visual representation of the final deployment of the use case. We will further demonstrate it step by step through 3 pipelines, starting with the first one, or optimization of existing public transport network. which focuses on supporting transport and urban planners to analyze passenger behavior to better understand travel patterns and preferences. Here you can see the GTFS real-time data viewer, one of the 3 datasets needed to run the trip chaining algorithm, and the only one that is neither stored by the city nor available through the Latvian Open Data Portal, mainly due to its large data scale. There are 2 ways how to download the data. The first one is a simple option where you just select the date and hour. The second one allows bulk download, letting you choose a specific period. In this case, we selected July 2024 as it is the main period we focus on throughout this demo. Scrolling down, we can see a data preview, data schema, and visualization of vehicle positions as data points. There's also a nice feature that lets you view how vehicles move during a specific hour in space at that time. Next, we will switch to the Python window where we will run the trip chaining algorithm that fuses 3 datasets, GTFS real-time, static GTFS, and e-ticket validations. It takes a quite time to process, so let's jump straight to the results. Here is an example of how the results look in Excel. We have information on the date and time, trips and vehicle IDs. Of course, we can also see all the details about the entry stops. There's an extra column showing the delay between e-ticket check-in and the GPS track. And then the most interesting part, the exits that were successfully determined. After analyzing and aggregating the data, we can also visualize it, for example, in QGIS. Here you can see how the ODs look at the public transport planning zone level. Let's take one of the zones as an example for a closer look, say the Latgales neighborhood central area. And what we can see here are all the destination zones and the number of trips made to each of them. After running the trip chaining algorithm, we move to the drop-off or destination prediction stage. This model uses ticket validation data to estimate passenger destinations, essentially completing the full OD table by filling in what trip chaining couldn't. Here on the screen, you can see the model's output in Excel using machine learning. It identifies patterns between where people check in and where they actually finish their journeys. By aggregating these predictions, we can analyze demand at a broader scale, in this case across public transport zones. And here in QGIS, the same results are visualized as travel pressure. Darker blue areas indicate zones with a net inflow of passengers, while lighter tones show outflow. This helps reveal the main attractors and generators of movements across the city, offering a clear picture of travel behavior. Now we are moving to the second pipeline, prioritizing public transport within the mobility hierarchy. This part highlights Riga's need for a data-driven approach to identify where public transport delays occur most frequently. Trajectory data analytics capabilities work across both desktop and cloud environments, but let's start by going through the process in QGIS. Here we open a ready-made model that extracts information from both GTFS real-time and static data. The workflow begins with trajectory creation, where our GPS points are transformed into movement paths. Then we move to event extraction, which identifies where each trip starts and ends. And after that, we apply trajectory cleaning to remove outliers caused by tracking errors, followed by trajectory generalization to reduce file size by simplifying the data. Now you can see how the final results look. On the screen, we are showing around 30% of all public transport segments, mainly focusing on the central area since that's where the most traffic congestion occurs. From these results, we can observe the intensity of delays at the segment level, even down to the detail of which road experienced delays at specific points along its path. We can also take this analysis further, looking at delays by weekday, by vehicle direction, or even by hour of the day. This allows us to identify clear patterns, such as slightly higher average delays during the morning or evening peak hours. Because of analysis is based on individual trip IDs, we can pinpoint the specific routes and locations where delays occur most frequently. And thanks to such detailed information at the segment level, it's also possible to calculate free flow travel times and compare actual delay against both the scheduled and free flow conditions. Now we move to the trajectory analysis extension in Carto workflows, which operates in the cloud environment. The logic behind how we obtain the results is the same as in QGIS. Here you can see the GPS points displayed directly on the map, along with the data preview on the side. If we click on one of the workflows, for example, split trajectories, we can also see an instant data preview showing how the information is processed at each stage. What's great here working in the cloud is that this makes it easy to analyze and visualize delays directly without needing to export or process the data locally. And finally, here you can see the final dashboard where all process results are brought together in one interactive view. The dashboard allows users to explore key indicators such as average delays and segment performance across the entire public transport network. In the map view, we can filter by route, day of the week, or time period to visualize where delays are most common. The charts on the side summarize network-wide statistics, making it easy to identify recurring congestion points or underperforming segments. Altogether, this tool, whether used locally or in a cloud-based environment, helps turn route trajectory data into actionable insights. And that brings us to the last pipeline, fleet planning and management, which focuses on optimizing Riga's public transport operations. In this part, the model predicts the number of entries and exits per zone for a given day of the week and time window. In other words, it forecasts when and where passenger crowds are likely to be denser. The tool is based on open source code. On the screen, you can see the notebook interface. We start by entering the inputs. First, we select the day number. Let's take 2 as an example. Then we enter the time, say 15:15. The system afterwards will highlight and confirm the selected day and time. And then we specify the zone. Here we will use Rumbula as an example. And after running the script, the model outputs the predicted number of passengers entering and exiting that specific zone and time window, providing valuable insights for planning vehicle allocation and improving service efficiency. Here we can see the predicted numbers of passenger entries across different zones throughout the day in QGIS, highlighting when certain areas become busiest over the time. Thank you for listening. I hope these tools and approaches presented here can be applied and adapted across other urban contexts. We'll be happy to share more and exchange experiences. See you in Riga.
Yep. So this is it from Emerald's project for Riga, use case 3. I'm open to any questions.
Thank you very much, Juris, and Christine also, because she is part of this presentation. Thank you very much, both. Thank you very much also to the SPINE project representatives. We have actually one question that is involving both the projects. I don't know who wants to reply first, or if you have any idea on this topic, because the question is, how can SPINE data quality approach, which is the topic that we saw important in the SPINE project, and Emerald's real-time analytics could complement each other in a single city's transport ecosystem. So a kind of complementary or synergetic, let's say, synergy concept.
Maybe, sorry.
Yeah, go ahead, Nadine. Yes.
Okay, yeah, maybe I can start. So from SPINE perspective and what I've now just heard from Juries is that so far, like the smart traffic management in Spine rather supports long-term planning, I would say, and also scenario analysis. And while, let's say, from what I now got is that in Emeralds, the cities are empowered by, let's say, reacting to live events, disruptions, and so on. And I guess like having this analytical approach first and kind of topping that up with what you do in Emeralds, it's, I guess, a really powerful tool then, so to say, for cities to improve. But maybe, Juris, you can also share your perspective.
Yeah, I wanted to say that we had implicit kind of data quality control checks in the project, and actually data quality is a big issue. And non-existing data, wrong data, and having explicit algorithms for data quality check would be very useful. So let's say if we are presently at TRL say 5.6. If we are to proceed further, this is something that we definitely might get advantage of.
Great. Yeah, and also we have another question, which is more on the as a projects that they are Emeralds at the end and the Spine close to the end because it's 1 year close to the end. What advice would you give to other European cities looking to adopt similar data-driven approaches to public transport management? So a sort of suggestion for other cities. I don't know who wants to reply to this.
Yeah, can do, or Nadine, you go first. Definitely have some insights.
Okay. Yeah, maybe as I also mentioned in my presentation, for cities to, let's say, start early, kind of also being aware of their data and ideally also looking for standardized formats. I mean, it's not so easy given the complexity and everything, but I guess the data handling kind of thing is very important for cities to do. And also if they do not have all the data given, simulation might be an approach to fill the gaps there. And of course, also sharing knowledge and lessons learned with other cities is, I guess, very important in that case. So these would be my 3 points to mention here.
Yeah, I would mention 2 points. One very quick takeaway. There's a lot of a wealth of data in real-time GTFS data. So, and we have Emerald project has developed a real-time GTFS data compression tool, which basically is very valuable because it's a very heavy data. So this is something you could do right away, like write to Trust IT and connect to us. We will share this data compression tool, which is very valuable. So, but that's like a very easy, like low-hanging fruit. But more strategically, I think it's how to put it, maybe not so much data-driven management as let's say action-driven data, because there's so much data. Like even in Riga case, there's so we can drown in data, and when we really start thinking, okay, but how do we use it strategically for urban development, then the answer is actually not that easy, right? So like a lot of analysis, you can do a lot of data cuts, but what do you need the data for? So I guess this is also something to really think about.
Yeah, great. And there is also a raised hand by Sisi. Hi,
yes.
Sisi. Go ahead.
Hi.
Yes.
So I just wanted to mention, complement a little bit what Nadine and Yuri said on a more broad level, let's say, not only for the data, but in general, what we have seen in Spain is that, this change that we want to make in the behavior on the people, etc., it sticks basically when the cities mix good data. So it's very, very important, but also, and I saw that this was also done in Riga, real citizen involvement. Involve the citizens, show them what you're doing, and then also different departments, let's say, actually work together instead of having like silos. So we've seen that all these three combinations, let's say, of evidence, inclusiveness, but also cross-department collaboration and with good data, that could potentially, if it's used correctly, have a lasting change. And have a lasting behavioral change, what we are looking for, especially in Spain, but I think in general in both projects. So yeah, my 2 cents on that.
Thank you very much, Cici. Yeah, this is very important and also interesting. I would say that the key word of this webinar is a collaboration and coordination, complementary, let's say, actions. So is for the 2 projects and also what you are saying. So talking not in silos, but also working, acting, and going beyond the vertical, let's say, topic that we are working on. So we are close to the end, actually, and I would like to thank all the speakers, asking also to Christine and the other speakers to switch on your videos, please. So just for a last bye. Bye-bye, and thank you very much. There is also a comment in the chat. And they're asking actually if it's possible to send this video presentation for the city of Riga. And greetings from Sarajevo. So thank you for the attendees this year, attending this webinar. Thank you very much for your contribution. So let's meet again on our website, our social media channels, and afterwards. Thank you very much, everyone.
Thank you.
Thank you for having us. Bye.
Bye.